Madhumita. Welcome, ma'am.
Thank you.
Madhumita, ma'am, is a gold medalist in MS and she's very experienced in the field of automation and control system. She's been an assistant professor for our department for the past 7 years. It's a pleasure having you here, ma'am. And before starting the session, dear participants, for your kind information, please note down your doubts and questions. Any query should be asked in the chat box during the live Q&A session only. A recorded version of this workshop will be available and shared to you for your future reference. As the workshop begins, from now on, Madhumita ma'am will take over. Hope you have a great learning experience. Thank you. Ma'am, you can start.
Yeah, thank you. So, a very good evening to all the participants of this workshop. First of all, I would like to appreciate your interest in, learning something new or spending your time off the college hours amidst your busy schedule to learn something about MATLAB. Okay. So, on the outset, I would like to inform to the participants that the intention of this workshop is just to give you a flavor of what MATLAB is. So just a basics of MATLAB such that which will help you in kickstarting your thirst for computational software for engineering and science and for programming and for solving engineering related problems. You wanted to begin with a software and you wanted to choose a platform amongst a lot of options that is available to you, and MATLAB will be one such environment. So the idea behind the conduct of this workshop is just to give you an introduction to what MATLAB is for someone who does not know about any idea of some kind of computation software that is available. Okay, so having given this, let us directly go into what MATLAB is all about and some basics of MATLAB which will give you an idea of what it is all about. Okay. I hope my screen is visible. And the objective behind this workshop, as I have just quoted, is to make the students of engineering, so you might be of might be from different streams, or might be from mathematics background, or from some other streams of engineering. So this objective of the workshop is just to kickstart your work, or kickstart your interest in using different softwares meant for computation. And one such software, as I told you, is MATLAB. And just to give you a basic idea of what MATLAB is, we will this workshop is on. Okay, so this basically helps the beginners from a very basic level to understand the basics of MATLAB as a programming environment, and also as a platform for scientific computation. So, having given this, what is a prerequisite that is expected out of you is a very little knowledge on computer programming. So, the intended audience for this workshop is basically first and second year students, so who might know some background about computer programming languages like C, C++, or Python, and so on. And some concepts like variables, constants, expressions, which you basically use in mathematics, different statements, structured loops, okay, and those methodologies or those programming constructs which are meant for implementing these scientific computations will be dealt. And so some theoretical knowledge on what these concepts are is required for understanding the concept that will be discussed in MATLAB now. So this 2-hour session will be in such a way that initially I will be giving you some idea about the MATLAB environment and what it is intended for. It will not be a theory session. Instead, what I want you to do is not merely listen to me for these 2 hours. Instead, you might have your own laptop with you. So please do start working along with me online to understand, to have a hands-on experience with MATLAB. Okay. So now let us start understanding what MATLAB is and what are all the features that it provides, and how does the environment of MATLAB looks like, and where do you think MATLAB fits into in science and engineering, or science and technology discipline. Okay. So MATLAB basically stands for Matrix Laboratory. This is developed by MathWork. So it is basically a computational tool which is useful in science and engineering applications. What basically it uses is a higher level programming, where the programming basically you do in MATLAB is to a level of abstractness. Okay, so in general, when we talk about programming something, there might be different types of programming that are available. One is which can be broadly categorized into two. One being programming platforms which are text based. The other is a programming platform which are graphic based. Okay, so accordingly you have two different types of programming platforms available, called text based programming environments and graphical programming environment. And MATLAB is basically a text based programming environment where any logic that you wanted to perform, or anything that you want to implement as a program, will be made in a language, as a text, where the functionalities of these texts will be inbuilt. Okay, so in text-based programming languages, you have different types or different levels of programming called low level, medium level, or moderate or higher level programming languages. Lower level programming languages are something which will have a very simplistic in nature, which are register level programmings, which will pertain to the hardware in which you are implementing the program for. Whereas a higher level programming language is a kind of structured, syntax oriented, where you use a specific language or a specific function to write the code for a program. Okay, and this higher level of programming language will have a higher level of abstractness in them, where a function which you basically write will be will in turn be coded with the help of lower level languages, which will be programmed to the registers levels that will be used in compiling and executing that particular function. Okay, and MATLAB, being a text-based programming language, is a higher level programming platform, and on the other hand, you also have this graphical based programming platforms available, where the symbols representing different functions, the icons or a kind of a block diagram representation of different functionalities will be available, and you wanted to connect them, I mean implement a logic by connecting these symbols, icons or blocks, which will give you a kind of a graphical representation for the logic that you wanted to build for an application. So there are different pros and cons that you will have for a text-based programming language as well as for a graphical programming language. And when we talk of MATLAB, MATLAB comes under text-based programming language, which is a higher level one, where there are built-in functions and built-in commands that are available in MATLAB, using which you can build your own logic for the application you are developing. And MATLAB basically provides an interactive environment which is meant for numeric computation for science engineering problems. It also provides a very good visualization tool by graphically creating displays, graphically representing the data that you wanted to analyze, and you also have graphical interfacing units, interfaces, graphical user interfaces GUIs that can be developed with MATLAB, which helps in a higher level of interaction with the system that you wanted to develop. And so this interactive environment of MATLAB actually poses a very huge advantage, both in industry as well as in academic environment, because it is very simple to learn, it is very user intuitive, and it is supported by very good documentation that is available. Okay, so MathWork in its website provides all the documentations that are required for understanding the programming aspects of or the functionalities that MATLAB provides, which will help us to, you don't actually need someone to teach you what MATLAB is all about, or learn or learn from any dedicated workshops like this, or from any training courses that you wanted to undergo. Instead, provided you have the interest to do programming in MATLAB, to learn the different aspects that is supported by MATLAB, you are always open to access MATLAB MathWork website to understand all the aspects of it. And recently, MATLAB has come up with online MATLAB, where you can log into MATLAB MathWork website and you can use MATLAB online, and that is what we are going to do for this session. Okay, so this vast library of built-in commands and functions that are available in MATLAB helps in developing your complex application to any level of abstractness that you want it to. Okay, so then what it is all about, or what all the functionalities that you can think you can do with MATLAB is starting from solving simpler expressions which you encounter in day-to-day life or in your mathematics course, where you study something about linear algebra, different transforms, solving differential equations. So all kind of mathematical computations can be performed in MATLAB. So MATLAB, how does this name actually came? Is it stands for Matrix Laboratory. The idea behind MATLAB's functioning is that every variable that you use in MATLAB is actually saved in a matrix format. The reason why a matrix format is preferred to save the data that you wanted to use in MATLAB is that it provides ease of access and ease of computation, especially when you're doing it with a digital computer. So any data that you want to store in a matrix format can be easily accessed with its rows and columns. So by specifying the row index and the column index, you can specify any element in a matrix. And similarly, you can store any number of elements in a matrix by increasing the number of rows and number of columns. So you basically have a compactness in representing the data that you wanted to represent. And once this kind of compactness of data is available in a matrix format, and mathematically computation with a matrix is also easier. Think of in your linear algebra in your school days, or in your basic mathematics courses that you would have undergone in your first year or second year of study. You would have had many matrix, especially with respect to linear algebra courses, you would have done matrix computations, where manually performing computations or calculations with matrix might be difficult for you when the size of the matrix is larger. But think of you wanted to automate it with a program that you wanted to write. So it is irrespective of what would be the size of the matrix, you can basically access the elements of a matrix by merely programming the index of the particular element across the row and across the column. So in that way, matrix multiplication is the way in which you store data in a matrix format, and the way in which you wanted to perform operations using matrix is highly significant and highly easier with respect to a programming platform like kind of a computer where you are running it. Okay. So thus, MATLAB basically performs matrix manipulations, which is the fundamental of MATLAB, called matrix laboratory. Okay. So all the data that you wanted to put in will be stored in a matrix format inside MATLAB, and any computation that is being performed in MATLAB will be in terms of matrices. Okay, so keep this in your mind. And what else functionality that MATLAB can provide to us is it is useful for implementing mathematical functions, storing data, representing or displaying data, providing a very good way of visualizing it by plotting the data, plotting the functions that you have, and you can develop your own custom algorithms for an application or make use of algorithms that are already existent in MATLAB. And it also helpful in creating a GUI which can be in real time be interfaced with hardwares, and the data acquisition in real time can be performed, and your system can act, your computer with MATLAB environment can act as a control platform for controlling your hardware device that you have interfaced with. Okay, and apart from this, and one thing that you would like to I would like to emphasize is that MATLAB is basically a proprietary software, which means it's not available for free. It's not an open access software. Okay, so only if you have a user license in MATLAB, you can have access to, and you can have access to all the toolboxes, all the features that are available in MATLAB. Okay, so there comes a need, like you need to have a license to be purchased from MathWork to make it, to have access to MATLAB. And at SRM IST, we have a institute level or university level license that is granted or that is brought from MathWork, where individual user of our institute can have access to MATLAB by signing in with your SRM IST mail ID into MathWork website, and you can download your own version of MATLAB. Okay, so you can download it in your laptop later, and you can start working with MATLAB, provided you use your SRM IST mail ID, and a dedicated license will be allocated to you. So we basically have a campus-wide license bought from MATLAB or from MathWorks at SRM. Okay, so having given that MATLAB is a proprietary software, so what it is capable of? So is it like only the product of MathWork or only the components of MathWork that you can use? Yes. Apart from that, you can still be have the possibility to access the programs written in other programming languages, the models, like if say think of you have made a CAD design of a mobile robot or any mechanism which you wanted to analyze with MATLAB. Okay, so you wanted to import the design that you have just made it. So you have this option of importing any program or any part of the module which is written in some other programming languages or some other software development platforms, and that can be imported into MATLAB, and then the analysis of that can be carried out in MATLAB. Okay, so this analysis of data, development of algorithms, and presenting the data and visualizing the data is all possible with MATLAB. And apart from that, from system development side, where from scratch you wanted to system development cycle or product development cycle comes in, where the very first stage that one would be interested in is to create a model of the plant which the person wants to work in real time. So once you create a model representing the plant, you wanted to analyze whether the model could really represent the physical system that you are going to design or not, which could be either done with a prototype you can develop, and this prototype will require a hardware which you will make with the components selections and then integrate them to start working with it. And if it does not provide a satisfactory result, then what you basically do with is you model, you actually tweak again. So to improve your model, and then you go for prototyping again and then develop your system. But prototyping directly in terms of hardware is basically a time consuming as well as a highly expensive process where validating your model might require iteration. Okay, so which could be done very well with a kind of a simulation environment like which is supported by MATLAB. Okay, so once you develop a model of a physical system, that model can be implemented in simulation in an environment like MATLAB, where you can try to analyze the performance of the system in MATLAB, performance of the model that you have developed in MATLAB, and if you see the performance is satisfactory, then you can go for building your system into a prototype or into a physical system. If at all the model is not satisfactory, you can go in for varying the model parameters. You can go for varying the settings that you give for the system, vary the inputs that you can give for the system. Everything is possible only if you do it in simulation. Okay, so all these variants for your model you can apply in simulation easier, and then you can validate your model upon multiple iterations. Nothing restricts you from it. Okay, so all this way of modeling and simulation, which is a very prominent part or a very prominent stage in the product development cycle, is supported by MATLAB. Okay, and even for mechatronics engineers perspective, because I suppose most of the students here would be from mechatronics engineering branch. So from a mechatronics engineer's perspective, this stage of modeling and simulation, designing control aspect or analyzing your system, all this could be very well done with MATLAB. Okay, so modeling and simulation is a very indispensable step in product development cycle, especially with respect to mechatronic system design. And so I would strongly suggest using MATLAB for modeling and simulating any system that you wanted to develop further. Okay, so what are the aspects or what are the features that we have in MATLAB now? Okay, so MATLAB, as I told you, is a text-based programming language. Okay, so where you can perform all the mathematics-related operations, all the operations that are relevant to the real-time scientific and engineering domain. And so you have a lot of toolboxes available that are possible, that are developed to support the real-time systems that are present in engineering disciplines. Like we will shortly browse through all the toolboxes that are provided in MATLAB. Okay, so MATLAB is a text-based programming language, as we had discussed earlier. Apart from that, MATLAB also supports a platform inside it called Simulink. Simulink is basically a kind of a programming language in graphical programming environment, which is meant for physical modeling of systems by a block diagram formats which you have for different functionalities that is presented, which is useful for a graphical representation for a real-time system. Okay, a real-time dynamic time invariant or time variant systems, whatever you wanted to simulate into in a graphical program way, you can use Simulink. Okay, so this so what you're seeing on the screen is basically the different or a very vast category of toolkits that are supported by MATLAB and Simulink, which are available as a text-based programming languages and as well as a graphical programming language to the right. So apart from basic computations with mathematics, you can have a lot of other applications developed with MATLAB. Like you can do parallel computing, as artificial intelligence is booming like anything. You need a platform to work with, and data science, statistical analysis are all a broad category where which is seeing enormous improvements, okay, and which is supported by MATLAB. You have optimization toolbox for any optimization and mathematics applications, functions related to this. When you wanted to develop your own code in different other programming languages, you have MATLAB code generation available. You can have a specific category of toolboxes that supports application development, application deployment, and you also have a category of toolkits that are meant for database management, especially with respect to computing and information technology, is presented for database management and database access, generation of reports, generation of codes. All these are supported into a vast category of toolboxes that are confined into these different categories. So, in the same way, those toolboxes or those techniques that are available under Simulink is categorized into multiple techniques. Like you have those features or functions developed in Simulink which would support physical modeling, event-based modeling, real-time system simulation and testing for generating codes, for verification, validation, and the testing of the system that you have developed, and functions that are meant for application deployment, and for simulation of graphics and report writing. Okay, I mean report generation. Okay, all this are possible with MATLAB as a text-based programming language and Simulink as a graphical programming language. Okay, and then what are all the toolboxes that we have in MATLAB? We will go through this as I have. This is merely a list. Say some students might be interested in, say, those who are from automotive industry or from automotive engineering background, or those mechatronics students who are interested in automotive sector. So in order to simulate or in order to control or understand different automotive plants that you wanted to develop a model of and control it, you have dedicated automotive toolbox. You have toolbox for aerospace industry, and for design of controllers you have control system toolbox, and you have a dedicated toolbox for image processing and computer vision applications. For communication, for students of electronics and communication, where you wanted to simulate any communication process, be it wired or wireless, you have dedicated communication toolboxes, signal processing toolboxes available, and those which are meant for statistical analysis, computational biology, computational finance, and for VLSI design or system on chip design and development, you have FPGA, ASIC, and system on chip development toolbox available. And you also have code verification category of toolboxes that are available in MATLAB. Okay, so especially with respect to computational mathematics, the reason why basic computation with mathematics is given emphasis to in this workshop is that, as I told you, it is a very basic level that we wanted to start with MATLAB. And uh, having given this introduction to MATLAB, I cannot directly go into solving a model of aerospace system or model of an autonomous vehicle directly into MATLAB. Instead, something which is relevant or which is basic about some mathematics of behind engineering is to be dealt. So, for which computational mathematics and implementation of it using a software like MATLAB is required as a basic to understand, such that you can go for higher level of implementation. And so when computational mathematics comes in, you have a lot of things that you can do with computations, like computation with matrices arrays, plotting graphs, solving linear algebra, algebraic equations, linear and nonlinear equations, statistics, data analysis, solving integration, solving differential equations, and say you might have learned about the transforms in your different levels of math courses, like Fourier transform, Laplace transforms, Z transforms, and so on. So discrete time and continuous time, whatever it is, and all these different types of transformations, which are basically mathematical tools available for analyzing different physical systems. Okay, so all these tools can be implemented in MATLAB in MATLAB. Okay, so that is the reason why this computational mathematics is forming a basis for understanding MATLAB. Okay, so now let us start directly. Let us dive into the MATLAB environment and try to understand what it has or how the MATLAB environment looks like, and then we will start implementing a few basic codes or basic built-in functions in MATLAB to understand the environment of MATLAB. Okay, and then what I have planned or reserved for today's class is we will have a basic introduction to MATLAB environment, how it looks like, and then how data can be represented in MATLAB, what are all the data types that MATLAB supports, and and more emphasis will be given to computational mathematics, like especially with respect to matrices and arrays. So how do we represent an array, how do we represent a matrix and a vector, or how do we access, or what all the functionalities that could be performed with vector and matrix, and logical operations, arithmetic operations, and then we will end up the session with plotting. So how do we have, how can we develop a plot of the data that we have, and how do we make the plot more reasonable, or more in a more readable format. Okay. So what I want all listeners to do now is, please open up your own laptop, and I'll also do simultaneously when I'm as my screen is shared. So I want you to open up MATLAB window. So as we have a plan of using online MATLAB, if you're already introduced to MATLAB environment, you may open up install MATLAB software if at all you have. If not, you may go to Google and browse through MathWork or MATLAB. So I'll just give MATLAB. So what you basically see is it returns you mathworks.com website. So when you click on MathWork, so it goes to Indian website for Indian Indian website of MathWork, and what you can go do is, just for an introduction, you can go to products, click on products, and you will have all the products that are available under MATLAB family, under Simulink family, as you could see from here. So you have all these toolboxes. Say native MATLAB or native Simulink is just meant for computation of computational mathematics. Okay, and later on, as it is extended to multiple engineering related problems, or multiple functionalities that is being developed, more and more toolboxes were developed and made integrated with MATLAB, such that these toolboxes will basically help you in simulating the different physical systems that you have. So we have this kind of toolboxes, as you could see from here. Like under parallel computing, you have parallel computing toolbox, MATLAB parallel server. You have curve fitting toolbox, optimization toolbox, symbolic math toolbox, mapping, partial differential equation toolbox. So what these toolboxes is all about is, when you have a built-in function to be used for, say for example, I have a differential equation and I wanted to get the solution to that differential equation. So how you physically do is, you mathematically implement a solution for solving this differential equation, and you solve it to find the answer. But what these toolboxes inherently have is, they have as a built-in function. Upon calling the built-in function with passing these input as a differential equations as arguments, it just returns you the solution. Okay, so these built-in functions are provided in these specific toolboxes available under different categories. So you have for statistics, data science, and artificial intelligence. You have MATLAB code generation. You have MATLAB coder, embedded system coder. Okay, and you also have application deployment. For the sake of application deployment, you have a specific MATLAB compiler, SDK, product, and web server, and so on. Okay, and apart from that, for Simulink environment also, you have different types of toolkits, different types of Simulink libraries that are available for modeling your physical systems. Like, you wanted to model a electrical system, you want to model a hydraulic and pneumatic system, or a mechanical system, you have dedicated libraries that are available for all this. So apart from this, for developing specific applications pertaining to the application side, you have all these toolboxes that are available. Like, if you are interested in image processing and computer vision, you have all these toolboxes: image processing toolbox, computer vision toolbox, lidar and vision, and so on. So you have wireless communication toolbox, and going on to control systems, you can model your model your system using control system toolbox, system identification, fuzzy logic, Simulink. You have different types of toolboxes available for your control systems. Similarly, you can just go through all these different toolboxes that are available for supporting multiple systems. And those who are interested in or who already found your orientation towards a particular area can very well explore these different toolboxes and start working with it. And one thing that I would like to emphasize is these toolboxes or these functions that we use in MATLAB cannot be memorized. It is upon usage or upon exploring as you start working more and more that you will get used to. Okay, so think of all these toolboxes and all these functions within these toolboxes, no one can memorize. Even the one who developed it cannot memorize. Okay, so it is upon using help of documentation or inherent help that will be available in MATLAB window that you can make use of all these features that will be available in these programming environment available in these toolboxes. Okay, so that is with respect to introduction to what are all the products that are supported by MATLAB. And as I told you, it is an introductory level, so we will not be using any of these toolboxes. Instead, we will use native MATLAB to understand these computations related to mathematics. Okay, so I would like you to open up MATLAB online. So you will have an option for under cloud solutions. You will have an option called MATLAB online. Okay. So you might click on MATLAB online. Okay. So you have an option to start using MATLAB online. Okay. So when you click on MATLAB online for the first time, it would prompt you to register in MathWork website for accessing. And as I have already, maybe I would like to log out and come again. So it basically asks prompts you to give your email ID if you're already a member, or if you are not a registered member with MathWork, you will have to create your MathWork account from new. And for which I would suggest you to use your SNMIST mail ID, because as we have purchased the campus-wide license, you can have access to it and you can download your own license copy of MATLAB software. So I have already registered. I think it will take a very few steps. Maybe you can do it even live now. So I have already registered, so I'll just directly go in. Okay. So this is your basic MATLAB window, which is being displayed here. Okay. So there are four important things that you would like to note on this MATLAB environment. Okay. So one is called as the current folder. Okay. So the current folder is basically the place where all the programs that you make inside MATLAB is. So this is in cloud storage basically. But if you have an installed version of MATLAB in your system, this current folder is a place which is a current working directory of your MATLAB software when it is installed in your system. Okay, so this current folder will basically have the path where MATLAB is installed, and all the programs that you do in MATLAB will be stored in this current folder. Okay, and then what you have here to the next is called as workspace. So workspace is an area which actually stores all the variables that you have used in your program in MATLAB. Okay, so it gives you information about what is the name of the variable, what is the type of the variable, what is the data type of the variable, what is the value stored in it, and what is the size of this variable. Okay, so all the variables that you use in a particular program in MATLAB will be available or will be displayed in this workspace. And then the most prominent thing in your MATLAB is the command window. And what you see here by this double arrow mark and this entire region, what you see here is called as a MATLAB command window. So this MATLAB command window is an interactive environment where it acts both as an input interface as well as output interface. So this is a place where you can give input to your system, and the moment you give a single line of code as an input to your MATLAB command window, it executes that particular line and it returns the output of that particular line of code in the MATLAB command window itself. So this command window is basically both input and the output screen that you have, console that you have here. Okay. So, and apart from that, you have something called as a command history. So you can get it from a layout. Go to layout. You have something called as command history. So I'll just keep it docked. Okay, so what you see to my right is called as the command history. So this command history is basically the place which stores in memory all the commands that you have used in near future. I mean in the past. Okay, so whatever command that you used earlier will be saved in your command history, and you can have access to this software. I mean to this commands that you have used so far. Okay, so these are the commands which I used long back earlier, so it's still available under my account. Okay, so these are the 4 prominent windows that are available. So this is about the MATLAB environment. And then how do you start typing in your code in MATLAB? Okay, so a code in MATLAB is also called as a script. Your program in MATLAB is called as a script, and what you can do in command window is at one time you can give a particular single instruction and get its output. And as I told you, MATLAB uses built-in functions or built-in commands. So what if you give some other name which is pertaining to a built-in command for MATLAB? Can you use it? No. Okay, so there comes, and MATLAB basically comes with some kind of a special variables and constants that is inherent to MATLAB itself. So now let us try to understand that first. Everything we will do in MATLAB command window for basic understanding, and then we will go into a script as a program file separately. Okay, so anything that I type, say for example, I would like to type a number, for example, a is equal to 5. So I'll just type a is equal to 5 in the command window. When I press enter, that particular instruction pertaining to a is equal to 5 will execute in MATLAB and it will be returned as an output. You can see I'll press enter. Okay, so please note down that a is equal to 5 is an input that I have given here, and this line is executed and it is shown as output in the command window itself. At the same time, have a look at the workspace. The workspace now is populated with the value a, with the variable a, whose value is 5, and it is only one element, which means it has one row, one column, and it belongs to the data type double. Okay, and if you see the command history, the command a is equal to 5 is available here. Okay, that is the last used command, so it is updated. Okay, and about the data types that is being used in MATLAB. If you see, while programming, you would like to write codes or instructions with texts with alphabets or characters and strings. You might want to use numbers of different formats, like you wanted to use signed integers, unsigned integers of 8 bits, 16 bits, 32 bits, 64 bits. You wanted to use floating point numbers of single precision or double precision. You wanted to use Boolean logic, so where the data type is true or false, only 0 or 1 is available for a Boolean data type. So you basically have different types of data types for the data that you wanted to store in. Okay, and how MATLAB knows what data type that it is actually a variable is in is, if you see here, I have just typed a is equal to 5. I didn't specify whether it is an integer or I didn't specify what it should be basically. So MATLAB, what it does is when it has an assignment for a value, say when it is given a is equal to 5, it is a value. This value, the variable, it will basically check and it will assign itself of its own the data type pertaining to that variable. Okay, so a is equal to 5 is by default chosen as a double data type that is present in the MATLAB window, MATLAB environment. So now I'll say I wanted to type a string. Okay, so I'll type B, and whatever I type as a string, a string is nothing but a group of character. I have to specify inside single quotes or double quotes in MATLAB. So I'll give a single quote. I'll say good morning. Okay. So if you see b is equal to good morning is a last typed command, and I didn't specify that it is going to be a string. Instead, if you go through this workspace, what it does, the variable b is a value, it stores value of good morning, and its size is 1 by 12. Okay, so each and every character is counted, and it is of a data type character. Okay, so this is how MATLAB, when it is running, when a value is being assigned to a variable, it automatically assigns the data type to that variable based on the data that it is receiving, and it allocates memory wanted. And say for example, I have a is equal to 5. So I have a is equal to 5 for a double data type, memory for a double data type now, which is deep. If I wanted to replace, say a is equal to hi or hello world. So what it basically does is, this a, which is a variable, is now replaced into again a character, and earlier the memory allocated for this variable a was pertaining to a double data type, but now the value of memory that is allocated for this will pertain to store this character automatically. So in this way, any variable that you use in MATLAB will assign the data type and assign the variable and the memory, assign the value, assign the data type and the requirement for memory of its own. Okay, and if you see a is equal to 5 and a is equal to hello world, I have changed it. So what does this mean? The value which was 5 earlier is now replaced by hello world. So no longer a is equal to 5 will be available. So if I now think, say a value of a, the variable a will still be storing the value of 5, I am wrong. Okay, so the recent command for a variable will overwrite the value present in that variable. Okay, so this is one thing. And then let me type, say, so let me type again a is equal to 5. So the value of a is 5. I'll now type b is equal to 10. Okay, so the value of b is now equal to 10. So I have two numbers a and b. So now if I want to add them, I have to basically use the add operator. Okay, so what I'll just do directly is a plus b. I'll just type a plus b. I hope it's visible. So a plus b I'll just type in. And when I press enter, the answer for execution of a plus b will be returned. But think of, it is not assigned to any variable. So which means a plus b is 15, 10 plus 5, 5 plus 10 is 15, and it is assigned to a variable called ANS, which means it is a constant special variable which is used in MATLAB for returning the answer for any computation unless it is specified in the program directly. Which means, if you see c is equal to a plus b, I have given here. So when I explicitly give this, a variable c will be created whose value is equal to 50. But if I not explicitly created, if I had not created an explicit output for output variable for storing, then it will be stored in a variable called ANS, and ANS cannot be used by any other part of your program by the user program. Okay, ANS is a separate variable or a name of a variable that is used by MATLAB. Okay, so are there any other fixed commands used by MATLAB? Yes, there are a few. Let us see what they are. Okay, so for representing complex numbers, you might know that square root of -1 is the complex value that we would like to represent, which is represented in complex number as a plus ip in some notation or a plus jb in other notations. So these variables I and j are used as complex numbers and are special variables stored in MATLAB. So for example, I just give I. Let me see what I is. You see I is a value corresponding to this imaginary component, which is nothing but square root of -1. And so if you see answer, which is equal to 0.000 plus I plus 1, 0.00 I. Okay, So where if you see answer in this earlier case it was 15, and after executing this, the value stored in answer will now be replaced with you can see a complex double number. A complex number. Earlier it was only 15, a double value. Instead now it is going to be a complex number. So I just clicked on it, and you see it is 0 plus 1i. Okay. The same I have for the variable j. Okay. So 0, I and j are different notations but representing the same complex number. Okay, and these are fixed. And in order to denote infinite value, infinite number, this command inf, capital I N F is used. Sorry, INF is used in MATLAB, where INF denotes infinity. Okay, and apart from that, whenever the result of any computation produces a result which is not a number, which means you wanted to divide a number by a string by a number, or by zero or infinity, which cannot actually produce you a number, or you want to read the data from a file where the data is missing. So in the places of missing data, I cannot assume zero or any number. Instead, some value of an empty space is to be represented, for which MATLAB uses a command capital NAN. This NAN. Okay, so this N capital N, A capital N is basically a notation of not a number. Okay, so which means whenever a result of a computation or from the memory where your data has been accessed, if a number is not presented, MATLAB takes it or represents it as NAN, meaning it is not a number. Okay, so apart from that, certain values like pi, whose value is 22 by 7 or 3.14, is fixed. It is not going to change at all. So it is stored by the term pi in MATLAB. So pi is equal to 3.1416. Okay, so this value, so wherever you wanted to use the value of pi, you just type pi in MATLAB, and you cannot assign pi to any other function. Okay, so these are the different built-in functions that are available, and apart from that, you have a few other built-in special variables like EPS, which is meant for denoting the accuracy of the floating point number that you wanted to mention from MATLAB. Okay, so any results that you wanted to get through MATLAB, the accuracy of the floating point precision is represented as EPS, which is 2.2204 into 10 power minus 16 level. So that much amount of accuracy of your floating point number you will have. Okay, and now we have these variables now available. So let us understand some other few commands that will be useful. So as you could see the command window, you can see a lot of programs that is being typed in is all available. Say a previous program is still available, the one which I am typing is also available. Okay, and if you see here, all this might be while you're trying to troubleshoot or trying to understand your program, what you have done, it might be a little confusing or might be clumsy. So you wanted to clear the command window. So how to delete all this code that you have done is by using the command CLC. Okay? So CLC stands for clear command window. So this function, if you just type it clears all the command window from the previously entered variables or previously entered program commands. Okay, and then to check whether a variable is available is there or not. Say for example, I used this program. I have used 3 variables ABC, and I wanted to do a new program, or I want to write a new script, and still I wanted to use a variable ABC in that program. So the idea will what actually happens is the variables will be overridden. Okay, so all the data that was the result of the previous program will be lost. So to check whether such a variable is existent or not, I have a command called exist. EXIST, exist. So I just give exist and I give a name for a variable. Okay, so if the variable is existent, it gives a logic of high, give the logic 1. If the variable is not existent, it gives a logic 0. So when I say exist A, I'm checking, I'm asking a question whether there is a variable of A is existent or in MATLAB workspace or not. So what it basically gives, answer is equal to 1. So which means logically it is 1. Yes, it means a variable is existent. So it is better you do not use the same variable name for your other program. So let me check exist. I do not have a variable x. So I'll just check whether x is existent or not. It returns 0. There is no variable by the name 0. Okay, there is no variable by the name x, so it is not existent. So it returns a 0. Okay. Now, if I want to delete any single variable that is presented, I can just use a command called clear. Okay. So clear, I want to delete the variable a. Okay, so I'll just give clear a. You might see the variable a is deleted from the workspace. So if I just type a, it will say unrecognized function or a variable because I have just cleared a from the memory of MATLAB. Okay. Similarly, I can just give the command clear or clear all. Okay, to delete all the variables that will be present inside this MATLAB workspace or from the MATLAB memory. Okay, so this is one. And in order to have an idea of what all the workspace, what are all the variables that is used in a program, there is a command called who. Okay, so what it basically does is it lists all the variables that are present in the MATLAB workspace. So I'll just type who and I'll enter. And what are all the variables that we have presently? A is one variable, B is one variable, and C is the other variable. These are the three variables that we have here. And what are these variables inside? What actually is present inside these variables? I do not know. So what is the size of it? What is the data type of the value stored in these variables if I want to access? I can use the command whos, whos. So it lists all the variables present in the workspace together with its data type and the size of the variable also. Yeah. So when I typed whos, you can see the name of the variables are listed as B, C. The size are all 1 by 1. It stores 8 bytes of memory. It requires 8 bytes of memory. All it belongs to W class. Okay, so these are all the different commands that are used for getting started with the MATLAB environment. Okay, and then I want to clear all the variables present in workspace. So I want to clear the command window CLC. I'll use clear. I want to clear all the variables present in MATLAB workspace. So I'll just type clear. Okay, you can see all the workspace variables are clear. I can also give clear all. Variables I typed in, and if you see any variable that I typed in, that particular line is executed and output is available in the command window. If I want to suppress the output from the command window, I can use an operator called semicolon. Say for example, C is equal to A plus B. I just typed it. Okay, so if I just enter it, if I hit enter button, it will return the output as 11. It adds these two numbers and it returns the output as 11. It will be stored in the variable C and it will also be displayed in the command window. In order to suppress the output of a particular command from displaying, I can use the semicolon operator. Okay, so when using a semicolon operator, the function will be executed. Okay, the function will be executed. The value of this function will be available in the variable, but it will be suppressed from producing the output at the command window. So when I enter, you can see it does not return C is equal to 11. Instead, the answer for the computation is available here in C. You can see in C variable, the answer is computed and it is available here. Okay, but it is suppressed from display in the command window. So this is all about very basics of it. And other thing that I would like you to understand is help, which is very important even for a beginner or for an expert in MATLAB. Okay, so MATLAB has a very good documentation available which can be accessed by if you know the value, if you know the function and you wanted to know the syntax for these functions, you can always go to help of these functions and try to type in it. Say for example, I do not know what this CLC does, so I'll just type help and CLC. So help is a keyword to call the help function of to call the help for any function. So anything you wanted to understand, that function you can type it. So what it does, it clears the command window and it gives a home to the cursor. And when you also have options for related files for documentation. So I'll just click on for documentation for CLC. So it opens up the documentation window for MATLAB. So where you can have access to all the MATLAB fundamentals and all the documentations that are available to understand any command that is present in MATLAB. Okay, so it is always recommended that you type help and try to understand all the commands that will be available in MATLAB. Okay, so can I proceed or should we go for a break? Nitish?
Yes, ma'am. We can have a 10-minute break.
Okay.
ready with your questions for the Q&A session.
So we just had a discussion on the very basic commands that one would like to understand when you start working with MATLAB. So moving on to the other aspects of MATLAB, let us now try to understand how a number can be represented, or the format in which a number could be represented in MATLAB. So by default, a number, say if anyone could recall, I just typed pi to give the value of the value stored as in the pi variable. So it's an infinite number basically. After decimal point it can keep on going, but what MATLAB does is it rounds off to 4 decimal points, the 4 digits after the decimal point. So is this format defined in MATLAB? Yes, it is. By default, the format used in MATLAB is a short format. We call it as format short, okay, where the command format is used to display the format of the data you want to show. Okay, so this format short will basically take 4 decimal places, have 4 decimal places to return your result. Okay, so that is format short. So any number that I want to type in, say 10 by 3, it returns 4 decimal places for 4 digits after the decimal point. Okay. So this is about format short. If at all your computation requires that more decimal places, so more number of precision is required, and so more decimal places is to be included, and so you can go for long format, where format long, if you given, this is a command, so the data format will be set to long, which means any value that you use hereafter, the result of the computation will be stored as 16 decimal places. So the same computation that I'll do 10 by 3, now it returns 16 decimal places once it is set to format long. Similarly, the value of pi will also be set to 16 decimal places after the decimal point, and this is called as format long. And when you want to make it a very short format, then you use a format called bank. Okay? So this format bank will round off to 2 decimal places in MATLAB. So 10 by 3 will round off to 2 decimal places, pi will round off to 2 decimal places. And apart from that, you also have a format called RAT, which basically returns the rational number representation for any nearest computation that you have. Say I'll give for the same pi. Okay, so the number that it returns is a rational expression. Okay, so this is about the formats that you have. So apart from that, you have the formats for short e, okay, which basically represents the number in exponent power. So for example, it basically takes 4 decimal points pertaining to short form representation, and after that it returns to the power, it reduces to the power of the exponent and expresses the number. Similarly, you have format long e, where it takes 16 decimal places and then it raises to the power of e to represent it. Okay, so any number or any computation that you would like to perform will now be represented in this order. And now let me set it to the default value of default format representation of format short. So this is basically for your understanding when you wanted to read data or the computation, the format of the data that you wanted to analyze requires a specific format or specific precision levels that you wanted to ensure, then you can very well set the format of the data that you wanted to process with MATLAB. Okay, so this is about it. And then, okay, next, let us see some basic arithmetic operations that you would like to perform. Let us consider addition, subtraction, multiplication, division, and so on. Okay, so to do all this, I need to build a script where, if you see in the command window that we have typed so far, we just had a single line of code that could be written. But think of, for application development, you wanted to type in multiple lines of codes, and which is not directly possible in MATLAB command window. Okay, so for that case, what you need is basically an editor where you can type in your program and then you run from the editor. Okay, and an editor that is available, an editor is actually inbuilt available in MATLAB, and so you can, the program that you write, as you know, is called as a script. So you can basically develop a new script. So you have under home icon, you have a new script available. So when you click on a new script, you can actually have an editor window, inbuilt editor window of MATLAB that is available here. Okay, so you can see the command window is shifted below. You can also undock it. Sorry. Yeah. Yeah. So whatever I type in this will be stored as a single program, and I can run all these programs inside it. Okay. So every time I wanted to run my new program, I'll just type in TLC denotes, I'll clear the command window. Okay. And I'll also clear all the way, maybe I'll do not use this. I just clear the command window every time I write it. And I wanted to say type the numbers, say A is equal to 10 and B is equal to 2. Okay, and these values I just given, I don't want to see it in the output, so I'll just type in and I press enter. When I press enter, the value is not, okay, we will start from you. Okay. So I do not have any values present in the workspace, so I'll just give A is equal to 10, B is equal to 2. So these two variables are now available. It is not executed. Okay, I have to separately execute this program. Okay, and I can perform any calculation that I want to. Say, for example, I wanted to perform addition, so A plus B. And one thing you need to be very careful about when you're naming the variables is that MATLAB is case sensitive, which means a small letter variable name, a capital letter variable name makes difference in MATLAB. So you should use the same variable name that you use in, the same function name that you use in, because it's case sensitive. So I'll just give A plus B, I'll give A minus B. For multiplication, you have A star. For division, you have basically two formats. One is A divided by B, is denoted by a right backslash, as you could see from here. Okay, and then anything I want to rise to the power, I'll use the exponent symbol cap. Okay, so I want to rise A to the power B, I just give A cap B. This denotes it is raised to the power of B. Okay, so these 5 functions we will just run now. So if I want to run any particular line of code in this, I can just select a particular part. Say, for example, the first 3 lines of code I wanted to run. Instead of running a complete program, I just want to run only this particular command. I just select it and right click on, you have an option called evaluate selection. Okay, so only this part which you have selected will be executed. So I'll just click this, or you have this shortcut key F9 for it. Okay, so if you see, I have just run this. The two variables A and B is now available in the MATLAB workspace, and you can see in the command window the result is not available. Okay, and the other parts I can just run in. I have not assigned any variables to it, so it will just be replaced in as. And if you see, I do not have a semicolon also, so all the variables will be, output will be displayed. Okay, so I'll just go through here. A plus B, 10 plus 2 is 12. A minus B is 8. Then A 10 into 2 is 20. 10 by 2 is 5. 10 raised to the power of 2 is 100. And the last computed value will be stored in the variable named ANS. All the other variables will be overwritten. Okay, and so this is about it. By the basic variables, basic arithmetic operators. And you also have this left slash A left slash B. Okay, so this A left slash B is basically the function of B divided by A, mentioned like this. Okay, so when you give A backslash B, it basically computes B divided by A. So I'll just type it, I'll just evaluate this part. So B is 2, A is 10. B divided by A is actually 2 by 10 is 0.2. So that value is returned here. So the operator for doing that is backslash or left slash. Okay. So though you give A backslash B, it basically computes B by A or A inverse B. Okay. It is this function that is being computed here. And then you wanted to find the square root of any variable. So say for example, you cannot put in that symbol, square root symbol, right? So the function that is available is sqrt. Okay, so square root of 100 I wanted to compute, it is 10, the value will be available. So square of any value I wanted to compute, either I can just multiply it by using asterisk symbol or just raise it to the power using cap. So 3 square or 3 cube I wanted to compute. So the computation will be available using this cap symbol. Okay. So this is with respect to very basic mathematical arithmetic operators. Okay. And another thing that I would like to inform you is commenting the operators, commenting the part of your script. Okay. So you can use this single percentage symbol to compute or to denote any comment that you wanted to perform. So as a programmer, when you wanted to access, when you're writing a program and you want your program to be used by others, when you're anything you wanted to write as a comment to the person who is reading the program, you can use this. Say what CLC does, it clears command window. So something, any options that you wanted to say, what this does, it performs addition. So this part of anything that you type within this single percentage will be considered as comment by the MATLAB executor and compiler, and thereby it will not return you an error message when you run the program. So what about saving your program in MATLAB? Okay, so first thing, when you wanted to completely run all the program, all the lines of codes that you have written, you can use this command run, a run button that is available, or you can use the shortcut F5, function key F5. Okay. So when you do this, it will prompt for saving your program. Okay, so it asks for saving your MATLAB program. So is there any naming convention that you wanted to follow? Yes, definitely. A naming a MATLAB script should not use any special characters except for the underscore sign. So, and also the name that you use for saving your MATLAB script should not have a space in between. So it even consider space as a character. So space is not a character recognized for naming. Okay, so only the name that you use can have alphabets, can have numbers, but no other special characters except underscore can be used. So I'll just say uh, operators. So operators underscore 1 is the name of the file. And if you see, every MATLAB script is saved as a .m file. That is the extension in which your MATLAB file will get saved into. So operators underscore 1. So it takes both numbers, both alphabets, and the only special character that it takes for naming is underscore. So all the program completely it will be executed and it will return the output. And then this program within a single MATLAB file, .m file, you can actually split your program into multiple cells. And so you can use this double percentage to split, I'm sorry, yeah, you can use this double percentage to split your complete MATLAB script into different cells. So whichever cell is excited at that is active at that instant is shown by the highlight is shown or is highlighted as you could see. The cell that is active is highlighted in the kind of yellow color. And if you want to run the contents of this complete cell instead of the complete program, you can just click Control Enter as a shortcut. You can press Control Enter and that complete cell will be executed. Okay, so this is about this basic arithmetic operations that you can perform with the numbers. And now let us go into how do you represent vectors. Okay, so the next cell what I'll have is, let us try to put in how do you represent vectors or how do you type in vectors in MATLAB. Okay, so vectors are one-dimensional entities. It can be a row vector or column vector, and a row vector in MATLAB can be represented by separating these row entries by a semicolon, and a column vector can be a row vector which consists of only a row can be separated by the where the entries can be separated with a space or a comma, whereas a column vector can be separated where the entries of a column vector can be separated by a semicolon. And now we will see how it is done. Say let us have R as a row vector, which we will start with a square braces, and let us type in the vector element like 1, 2, 3, 4. If these are the entries of my vector, I can just give a space away, and this forms my row matrix, a row vector. Okay, and let me have another row denoted as x. Okay, so the entries of this row be 5, 6, 7, 8. Okay, so both are now, I am running this, and you see that R and X are not suppressed by semicolon, and so the result will be available here. Both are row vectors. Okay, the values are now available. Okay, so now how do I represent a column vector? A column vector is represented by C in square braces. Every individual row in a column vector is separated by a semicolon. So I'll just give 1, 2, 3, 4, 5, 6, something like this. So you see C is a column vector. The entries are 1, 2, 3, 4, 5, 6, where 1 is a separate row, 2 is a separate row, and so on. Okay, so this is how you give a vector. And when you talk about computation inside the vectors, there isn't, say, when you are manipulating between with vectors, a scalar and a vector computation can be done with the help of the same arithmetic operators as you have just used for numbers. But between vectors, two conditions, you have to ensure that the dimensions of vectors are maintained. Only then computation can be performed. And you use a dot operator to ensure that every individual entries are multiplied. Say, for example, I wanted to multiply the row vector R by 2. So I'll just give R star 2. Okay. So when I run this, it returns all the row vector multiplied by the scalar 2, it returns it. What if I am just doing it in the command window itself? What if I just give R dot star 2? Okay, it still performs the same operation because 2 is going to be a scalar. So it does not make any difference between R multiplied with 2 or R which performs element-wise multiplication with 2. On the other hand, if I have to perform multiplication of the two vectors R and X, say R star X, if I perform, it returns a error saying that using star is not correct operator for vector operation. So instead, R dot star operator I have to use to multiply between vectors. Okay, so if you see, element-wise multiplication of these vectors will be taking place. 1 will be multiplied with 5, 2 will be multiplied with 6, 3 will be multiplied with 7, 4 will be multiplied with 8, and the result is displayed here. Okay, so for element-wise multiplication or element-wise operation, you use a dot operator. Okay, say R dot star X. So this is one. Okay, the same is for, say, if you want to perform addition, R plus X I want to perform. Okay, so this addition operation will basically be resulting in an element wise addition for each and every element. It will ensure that the dimensions are correct. What if the dimensions are not correct? Say, for example, the first row has 5 entries, the second vector has only 4 entries. Now let me run this complete set. What it shows is R operator, you can see, yeah, R row, X row is available, C column is also available, R star 2 is, excuse me, yeah, here. It starts from here. Okay, 5 entries, 4 entries, and r star 2, which is multiplication with the scalar, is computed, but r star x returns an error message because first row vector is of dimension 1 by 5, the other row vector is of dimension 1 by 4. So there is an entry which does not find a corresponding entry in x vector, and so computation cannot be performed, so it returns an error message. So while performing computation with vectors, dimensionality is to be ensured. Okay, so this is about row operations, vector operations. And apart from that, you have multiple functions that you can perform with rows, like with rows as well as with matrices. So which are common for both. And now let us try to understand how do you represent a matrix, and we will see all these operations. Okay. So let me give A, capital A as a matrix. Maybe I'll split it into cells. Okay. So for better view, I have it like this. So I'll ensure the same dimensionality. So let me represent a matrix. So matrix, how do I represent? A is equal to, I'll give matrix, it's basically made of rows and columns. So rows I'll separate with the space 1, 2, 3. Column I'll separate with a semicolon 4, 5, 6, 7, 8, 9. So this is basically a 3 by 3 matrix. Okay. Now, I'll run this. You can see this command window. Okay, so A matrix is written. It shows A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a 3 by 3 matrix. And R is a 1 by 4, a 1 by 5 vector. Okay, now we will see different operations that could be performed with matrices. Okay, so first, matrices and vectors in common. In order to get the size, we will use a command size. So size of a matrix A, it returns 3 rows, 3 columns. Size of the vector R, it returns 1 by 5. So size is a command which returns the size in rows and columns. And then you have the command called the length, which is used to get the largest dimension if it is a matrix. If it's an array, number of entries present in an array. So for example, A is a 3 by 3 matrix. It has equal number of rows and equal number of columns. So the length is 3. You can see length is 3. On the other hand, the length of R is 5 because the dimension of this is 1 row, 5 columns. So it has 5 entries in the columns. So the length of the vector is 5. And to access the maximum entry that is present in a row, the minimum entry that is present in a matrix, you use a command max and min. Max of A returns the maximum entry that is present in the matrix A, but what it does is, if it's an array operation or a vector operation, it returns the maximum element pertaining to a single array. Instead, it is a matrix, so it returns, or it is a row wise, it checks which is a maximum entry. So sorry, column wise it checks which is a maximum element and it returns it. If you inspect this, the first column the maximum value is 7. Second column maximum value is 8. Third column maximum value is 9. So column wise it computes the maximum value and returns it. Minimum, similarly, it returns the minimum value column wise and returns that. Okay, when we compute for a vector max R, it returns the maximum entry that is present in that vector and the minimum entry that is present in that vector, which is 1 and 5 correspondingly. Okay, and then now let me define some other. Okay, let me define a random matrix. Say R is equal to, say, 1, 0, 2, 5, something like this. Okay, so this is a value of R now and it gets replaced. Now, in order to find the location of non-zero entries in an array, in a vector, you can use a command called find. So find of R basically returns you the indices of this, the index locations of this vector, which has non-zero entries in it. If you see, The index starts from 1, 2, 3, 4, 5, and it goes on. Where you have a non-zero entry, zero entry is present in the index 2, so it is not returned. So only non-zero entries locations will be returned by the command find. If you give find of A, okay, A all has a non-zero entry. So it just gives all non-zero entries of the matrix A. Okay, then you can have functions to sort it. So sort the vector R. Okay, the function for doing it is sort. So the value is sorted as 0, 1, 2, 4, 5. You can see this is a value I had. It is sorted in the ascending order. Okay, and this is about it. You also have function called product of all the entries that is present in a vector. So you see you have a value 0. So let us not take this. Let's have the x vector. And so I want to do the product of x. Sorry, product of x. It returns the product of all the entries present in x. Okay. On the other hand, if I perform the product of the vector a matrix A, it returns column-wise product and returns the value of it column-wise. Similarly, sort of A, it returns every element sorted in the ascending order row-wise. Okay, column-wise. Okay, so these are the options that are available for uh, row and column vectors as well as for matrices. Okay, so apart from this, you have functions for concatenating matrix vectors. Okay, say for example, I have a R vector represented like this, X vector represented like this. Say if I want to join these two vectors, I use a command called cat. It is meant for concatenation. Okay, so these vectors can be concatenated using this cat function, where you have to specify the dimension along which you wanted to concatenate, where along row you wanted to concatenate or along columns you wanted to do it. Say for one is a dimension meaning for row. So after the first row, the concatenation is to take place. So first will be R, next will be X. Sorry. First will be R, next will be X. Okay. So it returns that the dimensions are not matching because you see one is a 5 entry element, the other is a 4 entry element. So dimensionality is to be ensured. So let me modify X as 1, 2, 3, 4, 5. Okay. So now if I just run the same command, you can see the two vectors are concatenated along the rows. And along the column, if I wanted to concatenate, I give the column dimension as 2 and I just give enter. You can see all the first R entries will be present and then followed by X concatenated along the columns. So these are the row and column operations that you can perform for vectors. And then regarding matrices, how can you generate matrix? Every time you wanted to type in, or there can be some fixed matrix with which you want to work on. So you can basically create functions matrices using these commands. You have ones of, you can specify the dimension. This command once basically returns a matrix or a vector whose dimensions you type in as argument into it, whose values will all be ones. Say I give 1, 4. So it returns a vector of 1 row, 4 columns, where all the values are equal to 1. Okay. I can return ones of 5, a single number, which means it returns a matrix of dimension 5 by 5, whose value are all equal to 1s. Okay. These will be useful when you wanted to operate with constant matrices or constant arrays when you want to compute. Similarly, if you want to work with zeros, there is a command called zeros. You can specify zeros of 3, returns a 3 by 3 matrix of all zeros. Zeros of 3, 4 returns a vector of 3 rows and 4 columns whose values are all 0. Something like this. Similarly, you can create a matrix of identity matrix by the command called I. Okay, you can specify the dimension in it. Say I want to create an identity matrix of dimension 4 by 4, just call I of 4. It returns a square matrix of all values equal to 1, 1, 1 along the diagonal entry, which is nothing but an identity matrix. Okay. Then you wanted to create random numbers. You can do very well, where multiple commands following multiple distributions are supported in MATLAB. Say, for example, rand is a command for giving uh, for generating random numbers. Say I wanted to generate 1 comma 4, so I want to generate a random numbers randomly, whose dimension should be from 1 to 4. I mean 1 row 4 columns. So this rand command basically returns random numbers from 0 to 1 with the dimension that you specify inside it. Every time you run the same command, you will have different random numbers generated. Okay, so all this will pertain to only 0 to 1 random numbers will be generated. You have a command called rands, yes, where all, whatever you specify inside it will be taking random numbers from -1 to +1. Okay, again, every time you make it, it is -1 to +1, it returns. You can see you have a minus entry that is available here. You specify the row and column dimension, you get it. Okay, so this is about rands, and you also have rand I, which follows uniform distribution. You have rand n, which follows a normal distribution for generating random numbers. Okay, so this is about all this. And when you have a number which is to be rounded off, say I have a variable is it created with a random number of 1. So which means z is equal to 0.8235, and I want to round it off. So there are multiple commands for doing it. I have round off z, which will round off to the nearest integer, which is 1. I can also use a command called seal, which will seal it to the higher or an upper integer, which is 1 in this case. Similarly, if I want to say I give the command, I give 0.4 as a value for z, and I give seal to it, or I'll give some other value, say z is equal to 2.4. Okay, and I use the command seal of is it. The sealed value for 2.4 is 3, so it will return a 3 value. But when you round it off, round is it, what it returns is a round off value, because it is not greater than 0.5, so it will round it off to the lower level possible. Similarly, even though your value is larger, 2.9, sorry, is it is equal to 2.9 or something, you wanted to round off to the lowest possible value, so use the command floor of is it brings down to the lowest value. If you want to round off, you basically give a 3 to it, but you round it off to the floor, which is the least integer possible, is 2. So these are the 3 commands that you can do with it. Okay, with integer numbers, where you can round off to the decimal, round off to the nearest integers possible, any decimal numbers that you have. And you also have a command called magic in MATLAB, where I give the designation dimension of it as 3. So what it basically does is it returns a 3 by 3 matrix pertaining to a law that all the value that is present inside it will be have all the rows, all the columns will be having a same sum. It returns a 3 by 3 matrix. So maximum, it takes square of this. So 3 square is 9. So all the entries within this matrix will be within 9, and such that it will also follow that all the row entries sum will be same, all the column entries sum will be same, all the diagonal entries sum will be same. If you see, it will be 15 in all the cases. Similarly, I'll give 4. So 4 square is 16. So all the entries from 1 to 16 will be forming a 4 by 4 matrix. Okay, and it will pertain to this rule of this. Okay, so with respect to matrix computation, you can have options like you can find out the determinant of matrix. Say, for example, I use this matrix 3, 3 by 3 matrix A. To compute the determinant of the matrix, I use determinant. The command for it is det. It gets the determinant of this matrix. Computing the rank of a matrix is possible. So Either what you will conventionally do in linear algebra is you convert into echelon form, you find out the number of non-zero rows, and then you find out the number of rank of the matrix. Instead, the command rank of A will return you the rank, which is 3. Okay. Then trace, which is nothing but the sum of the diagonal elements, can be obtained using the command trace, which is equal to 15 in this case. We can also obtain the inverse of a matrix by using the command INV. Okay. How you basically compute inverse is 1 by determinant of A into adjoint of A. So this can be inverse of a matrix, provided it's non-singular, can be computed, okay, using the command INV. Okay, so these are all the other operations that one can perform with matrices. Okay, so now let us spend just a single minute, a single example to understanding about how do you plot a graph in MATLAB, provided you have a data. Okay, so let us give that for multiple intervals that you wanted to specify from a minimum to maximum number, where more number of data you wanted to give as input, you cannot manually type in. So you make, provided you know if it's a uniformly you have it as a format in it, then you can give this. So just I'll give x is equal to 1 is to 10. So from 1 to 10, it takes a default interval of 1 and it returns the number. And on the other hand, you can specify in what interval it explicitly wants to take. Say from 1 to 10 in intervals of 0.01. Okay, so if that's the case, you will basically have 901 entries possible from 0 to 0 to 10. So in intervals of 0.01. So all this interval that you can use. For this, you actually have a command called the linspace. Okay, so where you can specify the starting value, the ending value, and by default, it basically takes 100 samples. Say within 1 to 50, it has to return. It takes 100 values from 1 to 50 and returns. If at all you wanted to specify how many number of instances or values that you want, you can do that. I want only say 70. You can see from 1 to 50, it automatically divides or it linearly divides the interval, computes the interval and takes 70 numbers or 70 samples from 1 to 50. Okay. This is basically a linear scale. From one number to the other number, it basically has a linear difference, equal difference between the numbers that it takes. Okay. So now, let us try to plot a sine wave or any function, say kind of a parabolic function or a square or a cuboid function I wanted to specify. So let me specify time. Time. And now I wanted to generate a sine wave. For example, x is equal to, I have a command called sine of t. So while plotting, so how do you plot in real time is you should have, in a graph sheet, how do you plot? You need to have an x-axis value and you have to have a corresponding y-axis value. You plot it and join them. So even in MATLAB, you should have equal number of dimensions for plotting between the x-axis and the y-axis. So all the values of t that I'll have a corresponding value of x, and the value of t that it will have, that the value of x it will have will be a sinusoidal function of t. So use a command sine of t. So the command to plot is the plot, where the x-axis is t and y-axis I have as x. So when I run this, a figure window will get open up. Okay, so where you have the x-axis determined by t and y-axis, I think it's getting more time. Sorry, I'm sorry, I didn't specify it properly. It is 0 is to interval of 0.01 into star pi. Okay, so this is the interval I have for t. Okay, so when I run this, this cell, the window opens up, and you can see the command window that all the values of t and the corresponding value of x, 629 values of t and 629 values of x will be available, and it will be plotted in a command window. I mean, plotted as a figure. Okay. So this is about plotting a graph, and you wanted to give labels to this. So the command for giving x a label is this. You wanted to type the text. Let this be in single quotes. You give time, and in y label you give sine, say sine wave, and you wanted to give a title. The command is title, and what title you wanted to say, or I'll say in y-axis we'll say it's amplitude, and the title of the graph be sine wave. Okay. And so again I'll run it. You can see the time, amplitude, and sine wave is all displayed in the figure window. And in the same figure window, I want things to get overlapped. I want to plot another graph in the same figure window. I wanted to keep it wait. So I'll just say hold on, which means this figure window is held. And I want to plot something else. So I'll just give plot, okay, t comma. Instead of, x, which is a sign of t, I'll give something else. I'll plot something else like cos wave I wanted to plot. I'll just plot cos of t. Okay. So I'll now run this. You can see in the same figure, it's hold on, and a cos wave has been plotted. And there are two waves. You do not know what is representing which one, so you can actually switch on a legend. So I can give a legend, and I can give a label for the legend as sine as one and cos as for the other. Okay, so let me run this. And you can see the legend corresponding to this color of the graph has been created, and the default location is top right corner. You can also locate it by specifying bottom or left or whatever location, northeast, south, whatever direction you can specify as a keyword in it, and you can locate this legend. Okay, so this is about plotting a graph. If at all you wanted to have a discrete graph plotted, the command for it is stem. Say in the same graph whole, I'll hold on. Okay, I'll create a stem plot of t comma. The same instead of a sine wave, I just give tan of t. Okay, I just wanted to create a stem or a discrete plot of it. Okay, so I'll just run it. You can see that a tan function with respect to t is okay. I'll modify it such that to have a clear view. I'm sorry. I'll just run it. Yeah. So if you want a discrete plot, maybe I'll do it in the command window for better understanding. I open up a figure. Okay, this figure is a command to open up a new figure window. If you see, when I just type the figure, a new figure window is opened up, but there is nothing there in this figure. So what I want to plot inside this empty figure window is, say, stem of t comma x. Okay. So what you see basically is a distinct plot of, I would like to zoom it, because as we have 690 plus samples, it's very nearby, so you're not able to visualize it as a continuous graph. But if you see, as I zoom it along the time x and y axis, you can see instead of continuous time, you have instant distinct samples that's been plotted for individual time value. Okay, So these individual plots are being plotted, and distinct plot can be obtained from this stem graph. So apart from this, you can actually plot 3D plots, surface plots also, where all the data in the 3 dimensions you have to specify. You can also create a mesh plot, a surface plot using the commands mesh and surf, etc. Okay, so I suppose, I mean, these are basic or fundamental operations or visualization tools that you wanted to do with MATLAB. So apart from this, if at all during runtime a user want to give input to, again this I would explain now. Say there is a command called x is equal to input of input, where you can ask the user to give input command during runtime. So I'll just enter a number. So this enter a number which I put inside a single quote will be available as information to the user. So I can put a number which will be stored in the variable x. And now let me give y is equal to, say, some function in terms of x, say 4 star x square. Okay, so this is what I wanted to basically compute. So this I wanted to plot. So plot x comma y, or it's barely a number, right? So it's just an expression. If it's an array, I can plot it. So I'll just run it. You can see in your command window, it asks for an input from the number, input for the user. So I'll just give 2 as a number. So the result is 2 square is 4, 4 4s are 16 is being displayed here. Or any data you wanted to be displayed to the user, just use a command disp. Whatever you wanted to convey, say the answer is, or I would say this is basics of MATLAB session. So you just want this to be displayed. Just you type in the text that you type, or the number, or whatever special character that you type within a single quote inside this function will be displayed. So this will be helpful for creating a more meaningful script in your program. Okay, so thus we will end up our session with this. Though this is not all exhaustive, you haven't. So always try to keep in touch with any of the programming environment that you have made, that you are introduced to. So these are very, very basic and fundamental that you wanted to learn about MATLAB, though this is not an exhaustive list. You have a lot of functions and commands that are available in MATLAB, which I leave it to you, to your interest, to explore on using MATLAB documentation and help. Okay, so if time provides, or in some other workshops, we will try to dedicate some time through AME for an altogether very exhaustive use of MATLAB for numerical computation, or for a specific application like control or modeling, or computer vision or deep learning, or whatever it is. Okay, thank you all for having spent your time amidst your busy schedule in your academics in learning MATLAB. And now let me open up the session for any queries. Thank you.
Thank you, ma'am. Okay, so let's go ahead with the Q&A session. Participants, you can post your doubts and questions in the chat box below, and ma'am will start answering them one by one. So, ma'am, here's a question from Tanish Das. How to write multi-line comments?
Multi-line comments.
Yes.
Okay, so it is, you just use a single percentage. Excuse me, I'll show it up. Okay, so every line you wanted to type in, you just put in a command like this, or you use 3%. Yeah, multi-line comment you use with a percentage only. A single percentage comment you keep on putting in. Okay.
Okay.
Yeah.
So the next question, give me a moment, ma'am.
Yeah.
Okay, ma'am, here's a question from Pratik Sharma.
Okay.
Is the floor similar to greatest integer function or is there a separate command for it?
Could you please come again?
Is the floor similar
Floor?
to greatest integer function? Yes, ma'am, floor.
Floor. No, floor is actually the for a decimal point number that you have represented. Floor represents the lowest possible, nearest lowest integer possible. Say, uh, I have two values, for example, say 2.5, okay, 2.1 I have. The nearest integer for it is 2. On the other hand, 2.9 I have, the nearest integer, whole integer for it is 3. But what this floor command does is, it always brings down to the lowest integer level possible towards negative infinity, which means towards negative infinity for 2.1, which is nearest 2. Similarly, for 2.9, towards negative infinity, which is nearer 2. Okay, so it will pull down to a value which is negative, towards negative infinity. On the other hand, seal command will pull up your number towards positive infinity. So 2.1 you have, the nearest, so when you round off manually, you will keep it as 2 only. But towards positive infinity, the nearest possible integer is 3. So 2.1 will be sealed to 3.
Okay, ma'am.
Okay, and and for the previous question, I'd like to share my screen and about multi-line comments. I just recalled it.
Sure, ma'am.
Um, you can go for other questions as well. Meanwhile, we'll address that.
Yes, ma'am. Okay, so here's a question from Abhishek Lodha. Can we
Okay.
undo and redo in MATLAB like the Word document?
Yeah, you can.
Okay. And here's another one from Debajyoti Mandal. Is there any separate file extension for saving a MATLAB file?
No, it automatically saves as uh, .m only. But you also have other format representations like uh, .mat representation is available, which is used for, and you also have a structure format for storing your data. Kind of an Excel or a spreadsheet kind of representation is possible as .mat file format. Okay, but your program will be saved as .m file only. And you have a Simulink model. It will be earlier versions of Simulink stored as .mdl file, now as .slx file, and so on.
Yeah. Yes, another one from K. Sandeep.
Okay.
Why is the legend used?
To make more sense to your program. That's it.
Okay.
To any graph that you wanted to visualize, to make more sense of it, you wanted to, um, you know, you might have multiple. Say in a single graphical window, I wanted to plot multiple graphs such that I can superimpose each other and see what it means, what impact the variable has. So the idea is I wanted to superimpose the graphs and see, and so I will have multiple graph in a single figure window plotted, and I wanted to make sense for what each and every graph actually means. And so I need a legend. So what is first graph? What is the second graph? What it is? I need to have a meaning, right? So that is it.
That was a brief explanation. And yes, another one from Vedant Anand. So
Okay.
he has asked that can we use MATLAB for plotting and solving differential equations?
Sure, sure. You basically have, you know, uh, within a single day, if I directly go to solving differential equation, it might be difficult. You basically have inbuilt toolboxes as in the introductory session that I have discussed about a partial differential equations toolbox you have, where you can solve any order of differential equations in it using again features and functions inbuilt in it.
Okay, here's another one from Pratik Sharma.
Okay.
What parameters do we need to specify for plotting a 3D graph?
You have okay. you have to specify x, y, and x, y, and z, which means the values that you want to specify for the three dimensions. So across x dimension, y dimension, and z dimension, all the three dimensions that you wanted to plot a graph. Okay, say maybe if you want, I'll shortly give you the answers for the first question, multi-line comment. I would like to share it, okay, and plot a 3D graph also. I
Yes.
hope,
Okay, ma'am. You
yeah,
can.
is my screen visible now?
Yes, ma'am. Yes, ma'am. Yes.
Yeah. Just to have a look for a multi-line comment. As I told you, single line comment is for, single percentage is for single line, and the double percent is for dividing the cell. And if you want to give multi-line comment, you have to use a syntax star percentage, um, braces, flower braces, enter, and you use this three times dot operator for continuation. This you also use for typing your program lines. No, if you feel like your line of program that you wanted to type is too lengthy, and so you want to cut down and enter and then type it in the next line, you use these three dots. Okay, so the same three dot is used here also, and after that, whatever you type in will be taken for comments. Okay, so this is the syntax that you use for multi-line comment. So how do you end it? Again, you end it with three dots and close this, whatever you wanted to put, you put in, close with this flower base and percentage symbol. And that's it.
Okay.
Okay. Yeah.
Okay. Yes, one
And,
from Vasant Rajvi.
okay.
Yes, asks that MATLAB deals only with program based, or is it deals also with graphical interface presentation?
In MATLAB, you actually have a new version. You actually have GUI available where you can select the component. Let me show you if possible. Uh, yeah, you actually can generate GUIs in MATLAB where you can uh, in a text-based programming language itself, you can develop GUIs also. And as I told you, Simulink, you can see Simulink as you see here. Simulink is an environment where you can basically do graphical programming, where you have elements available as block diagrams in the corresponding libraries, and you can just copy paste or click and drag these components available in these library, and you can create a graphical programming language. But developing a GUI is different. Developing a graphical programming is different. Okay.
Okay. Here's the last one
Yeah.
from Abhishek Lodha. How do we use
Okay.
modulus function if you're using that symbol in the command line?
Come. What is it?
Yes, asked that how do we use a modulus function?
Modulus function. Okay.
Yes, if we are using that symbol in the comments.
Okay. So inside comment, whatever you put in, it will not be uh, taken into execution as a part of your program. So modulo operation can be performed in MATLAB using the command mod, mod. Okay, mod function that can be performed. Okay, so that should be done outside your uh, comment, uh, the sentence where you actually comment it. It should be away from it. That is only thing. You can use a command function mod.
Okay, ma'am. Yes, one more, ma'am, from Yash Krankar. Like sine, cosine, what other kind of functions are available in MATLAB?
Okay, so geometric functions you wanted to ask.
Yes.
So sine, cos are built-in functions. Apart from that, you have tan and inverse, tan inverse, uh, cos inverse, sine inverse. All these functions are available. And apart from that, you also have hyperbolic functions also available. You have an exhaustive list of all the trigonometric functions that you can perform is available in MATLAB. All that you wanted to do is just browse through and learn it yourself. because not
Okay.
all, because anyway whatever command or whatever time that I'm going to give as input to it, it returns the corresponding hyperbolic tangent, hyperbolic function, hyperbolic sine wave, and so on. So all these functions are available in MATLAB. All the trigonometric functions are available.
Okay, ma'am. So with that, we are ending our session for today.
Okay.
Thank you for having a session with all of us this evening, ma'am. Hope you had a great time.
Yeah. So not kind of an advice, because people don't like taking advice, but just if you are a beginner, if you are in your first year or second year of study, please do keep in touch with MATLAB environment when time permits, which will be really very much helpful in your academics as well as in your project. Thank
Okay.
you all.
Thank you, ma'am.
Thank
Pleasure
you.
having you today.
Thank you.
Thank you.